Welcome to the Philoctetes Center. I'm Ed Nersessian. Francis Levy and I are co-directors of the center. Today's roundtable is made possible because of the generosity of the participants who have come here to New York for this roundtable from as far away as California, Arizona, St. Louis, all at their own expense. And I want to express my appreciation and gratitude to them. In a paper published in 2006, Mark Alford, who is sitting here, Pete Hutt, who has been here a number of times, and Max Tegmark, who was here last year, presented the idea that views on the nature of reality and the relationship between matter and mind and mathematics and physics can be divided into three categories. Those views, or those who hold them, one group assumes that math and physics as we know it now, will explain reality and the relationship of mind to matter. Those who think math and physics, and then the second group thinks that math and physics can only cover a part of that experience, and I believe Mark is part of that group. And finally, those who think that current math and physics cannot or may never achieve that. Dr. Chopra will be moderating the roundtable. Dr. Chopra, having practiced Western medicine, internal medicine, and endocrinology is one field in medicine that the brain and the body have a lot to say to each other, became interested in Ayurvedic medicine about 30 years ago. Since then, he has become an internationally known expert, winner of many awards on Ayurvedic medicine, and has written over 50 books, 18 of which have been New York Times bestsellers. He is founder and chairman of the Chopra Foundation and co-chairman of the Chopra Center for Wellbeing in Carlsbad, California. He has agreed to moderate today's roundtable. Thank you.
Thank you, Edward, and I hope the sound is loud enough. Everyone can hear me?
Sure.
Okay, good, thanks. It's a great pleasure for me to be here and to be moderating this session on the nature of reality. And since I'm really the non-expert, it's really good that I'm doing it, because one of the things I told our panelists is I'll make sure that everything that's said is at least partially understandable. Okay? So what I would like to do is introduce our distinguished panel. Stuart Firestein here, professor of neurobiology and chair of the Department of Biological Sciences at Columbia University. Professor Firestein, thank you, sir. Mark Alford, professor of theoretical physics at Washington University in St. Louis. On my right-hand side there, Professor Mark Alford. Stuart Hameroff, Dr. Stuart Hameroff, also professor of anesthesiology and psychology and director of the Center for Consciousness Studies at the University of Arizona. And on my left-hand side, Professor Menas Kafatos, who's the Fletcher Jones Professor of Computational Physics at Chapman University in Orange County, California. So without further ado, since you all have, I think, their credentials, we'll start with this discussion. And I'll just ask two questions, and we have 5 minutes to answer. So we have 20 minutes gone there right away. First, and I'll start with Professor Firestein. Professor, do you believe there's an ultimate reality? And do you believe that science, physics, mathematics, biology, or any of the other sciences will get us to know it?
Well, that's a small sort of question.
And you have,
see what I can do
and
in
you
just
have
5
5 minutes.
Good, good. Yes and yes. Thank you very much. Yes, I do believe there is an ultimate reality. I think I believe that based really from the biological perspective simply of an evolutionary biologist, because I believe that you can You can imagine, you can hypothesize about what that reality would be based on how we have evolved in response to it. So, of course, there's perhaps much more of a reality out there than we're able to see, but I think Goethe said that the eyes are sun-like because there's a sun. The old conundrum of whether a tree makes a sound falling on a in a deserted forest seems to me to be almost senseless in terms of modern biology. Of course it does. If it didn't make a sound, we wouldn't have ears. I believe that if a fish, say, landed somehow or another on a planet far away from here with intelligent beings, they would be able to predict that the planet that fish came from was covered at least partly in water, because this is the nature of the fish. And so in that sense, I think there must be a reality out there. Now, whether we have a very direct perception of it, whether we see most of it or pieces of it, this, I think, is, of course, yet a big question. I mean, we're operating here with an instrument that was designed to find food and a mate before you become food, and it hasn't really changed a lot in evolutionary time from that, so it's remarkable we're able to do what we can with it. So how much of that ultimate reality we can finally perceive and understand, I think there may be limits there. There may not be. Everybody who's predicted limits has turned out to be wrong, so I don't really want to be in that line of debunkers. I mean, many times by very famous scientists in some cases. One field or another has been declared to be sort of finished. We figured it out. Physics is known to the last decimal point, I think, was a famous pronouncement in the late 1800s, just before Einstein came on the field. And so that turned out to be a kind of an embarrassing error. So I don't think it makes sense to take that point of view, because there's just no way to know. I would, of the three possibilities that you laid out, I would say the only sensible wager to take, in my opinion, is the third one, which is that mathematics and physics will explain the world, will explain the universe, but maybe not the current mathematics and physics that we have now. There may be a mathematics, physics that we have yet to come upon that would be required for a fuller explanation of that world. But I at least have, I can't call it any more than faith that could happen and would happen.
Okay, I'll come back to you about the sound of the tree.
I can also answer which came first, the chicken or the egg.
Okay.
That one too.
But I'll come back to that.
All right, we'll come back to that as well.
Before we, let's go to Professor Mark Alford.
Okay. So is there an ultimate reality? There's certainly a reality, and we're enjoying it right now. Asking for ultimate things seems a bit much. The point was just made that in science we've seen huge changes in our theories, in our scientific understanding of the world, and it seems foolish to think that our current understanding is ultimate, and it also seems hard to see how any understanding we had at some point in the future we would suddenly be able to declare ultimate. It seems more reasonable to me, rather than thinking of science and its goals in terms of ultimates, you should think of them in terms of improvement. We want to improve our understanding of the world. We want to improve our knowledge of the history of the universe and the human race and the planet and so forth. And you're always going to be improving and learning new things and being able to do new things as a result. And focusing on some infinitely distant ultimate goal is, it might be a good motivation for some people, but it seems like sort of a side issue.
We'll come back to whether it's a side issue or not. Dr. Hameroff, is there an ultimate reality, and do you think we'll get to it?
Yes and yes. I think there is. I believe in a observer-independent reality. I don't think we need conscious observation to cause collapse of the wave function to bring reality into view. I think if observers are not around, there's still a reality. I think ultimate reality is encoded at the very fundamental level of the universe, the Planck scale geometry, from which derive all the particles, forces, laws of nature, and I think consciousness is encoded at that level, at least at a proto-conscious level. So while I don't think we need conscious observation to create reality, I think that consciousness is intrinsic to the universe, at least in a precursor form, and that consciousness is not an epiphenomenon, but is actually built into the universe. And the Planck scale is very high energy. It's inaccessible at this time, but I think there's reason to believe that through future technologies and also perhaps the holographic principle that information repeats at higher and higher levels, that we can access it and come to appreciate it and come to understand ultimate reality. Now, there's another problem, and that is the difference between the quantum world and the classical world, because in the quantum world, which is generally small, particles can be in multiple locations, things are interconnected over space and time, all kinds of weird things happen, and yet we don't see that in our real world. And one solution to that is that conscious observation causes quantum things to collapse to definite things. I think rather that the collapse of the wave function occurs in the brain and actually is the source of conscious awareness. And I follow Roger Penrose's view of that there's a particular form of quantum collapse occurring in the brain. I happen to think it's in the microtubules, but that's another story. That gives our conscious reality roughly 40 times a second that we have a picture of reality, and that's a pretty good picture. And it's certainly not the ultimate reality because we're not seeing the quantum world, we're not seeing the origins of information and everything else at the Planck scale. But I do think that the Planck scale will be accessible one way or the other, and we will be able to know ultimate reality to some extent.
Professor Kafatos.
Yes, definitely.
There is an ultimate reality.
There is an ultimate reality, and the answer to the second quandary is maybe. I would say I'm optimistic, and I would say probably yes, but I will be a little bit cautious. In terms of ultimate reality, yes, it has to be there. Otherwise, we would not exist. We would not even make sense talking to each other if we didn't share some sort of reality that is out there. But to be able to understand it in the particular space and time era that we are right now is a little bit presumptuous on our part, I think. And in fact, as you were saying before, it was Lord Kelvin who predicted that we have reached the end of physics towards the end of the 19th century, and said, with the exception of two little clouds, and one was the photoelectric effect, and the second was the idea that somehow the motion of the Earth through the ether, what was called ether at the time, could be picked up, and in fact it turns out that you could not really see a difference in the direction of the movement of the Earth. So the first one, of course, ushered in a few years later the quantum revolution, and the second one ushered in the theory of relativity. So some of us physicists say that Lord Kelvin picked his clouds very, very well, and it turned out that both of these clouds became huge storms. So we have to be a little bit careful. And in fact, these days, the theory of everything, supposedly we're very close to rearranging everything in our physical theories and understanding the universe. But actually what is happening in that, we're talking about particle interactions or particle processes that may be some sort of string theory or supergravity may be able to get us there. It's got to be more than that. It's got to be more than space-time and mathematical descriptions. I personally believe that eventually we'll have to have a new mathematics that has to be brought in, because, in fact, as Roger Penrose has pointed out, trying to understand the process in the brain in terms of algorithmic, in other words, well-defined programs that are run like a computer program, it's not going to work. So there has to be the other aspect, complementary aspect of algorithmic development, which is, if you like, the qualitative aspects. So we need, I believe, a new kind of math that will allow us to probe the qualitative aspects as well as the quantitative. We don't have it yet, but one day we will.
Very good.
Can I ask one question based upon what you just asked?
Yes.
Is there a difference between the subject and the object in this case? In other words, can there be an ultimate reality which is not ultimately perceivable by subjects?
So, yeah, I'm going to address that because several people have raised that.
Right.
That's a good point.
The same point. Is there a sound without somebody perceiving it?
Exactly.
Is there an observer-independent reality? Is there a world independent of consciousness? Why do we want to know if there's an ultimate reality? I think these are very relevant questions for human beings. They've asked them in different forms, and perhaps not the same phraseology. Who are we? Where do we come from? Do we have a spirit or a soul? Does God exist? What happens to us after we die? And the questions really are the same, but clothed in a different language. This is the question I have for everybody on the panel, and please be very brief and succinct. If there is an ultimate reality independent of the observer or consciousness, how would we ever know of it? Anybody?
Well, I don't think there is, so I don't think there is.
So you just contradicted yourself. You said there is a universe independent of the observer a little while ago. But now you're saying that...
Oh, I see, yes.
I'm saying if there is a reality... First of all, there are three questions in this one question. If there is an ultimate reality that is independent of consciousness, is there any way we would know of it? Because it's outside our consciousness and we have no way of getting out of it. Second question, if there is an ultimate reality, is it uncreated? Because if it is created, then it's not ultimate. Okay. Third question, when we go to, and I believe you're a physicist with interest in cosmology, or background is cosmology.
Well,
astrocosmology. So let's go from what I've learned to the first few microseconds, 10 to the power of minus 43 seconds after the Big Bang. That little period, what I'm told, and I'm not the expert, is not only do we not know what happened in that period, but we'll never know because there were no laws of physics at that moment. So it's open. Please,
okay, well,
you take.
So I'm really an astrophysicist, not a cosmologist, but I think the thing about the Big Bang is that the further back you go, the less you know. You know, you're going further back in time, and it's harder to know what happened further back in time. We don't know much about, Sumerian comic drama, right? Because it's just hard to get that information. We know very little about what was happening at the very early stages of the expansion of the universe that we see now. So,
speaking mathematically.
Yeah, but if you're speaking mathematically, then what you're doing is you're taking some particular theory, model of that process, and assuming it's correct, all the way back through eras of physics and energy scales on which we have very little experimental information. So I think one should be rather agnostic about this. You know, we have theories. If we extrapolate the theories back, we get strange things like time has no beginning or there are no laws of physics. Sure, but we're extrapolating theories off, way off their beaten track.
Okay.
So that's my...
I take that.
Yeah.
I accept that. The remaining two questions, if there's an ultimate reality independent of consciousness, would we ever know how it exists, or does it exist? Is there a way of...
Consciousness or awareness? Then do we need to make a distinction between that?
Choose
Are we all
one
happy
or
we
the
can
other.
use either one of them?
Same thing.
Same thing.
Well, so I mean, in some ways, this may almost seem trivial, but I can't tell you about ultimates. I'm in agreement there with
Is
him.
ultimate uncreated? We haven't answered that question either. It's just a question.
Well, I mean, I just think it might be too far to bother with at the moment. Ultimate. I mean, it's just kind of way out there. We're not that far along yet in a way. I understand, but so I mean, clearly there are things we are aware of in the universe today that our very recent ancestors were not. Radio waves, microwaves, a whole slew of things that are beyond our awareness in the sense of the sensory apparatus that we work with, but are clearly not beyond our, if you will, consciousness or our ability to know about them.
Aren't there mathematical laws in our consciousness, or don't we experience them in our consciousness? Isn't science an experiment in consciousness?
Yes.
Yes, but I don't know whether mathematical laws exist in our consciousness. I mean, I guess it's a kind of a
I was
almost
going to
platonic
quote,
sort of question, right?
Eugene Wigner, who says it's it's almost uncanny that mathematics, that is an activity in our consciousness, somehow corresponds to the laws of nature. So there must be some link, right?
Well, I mean, there may be a link, but mathematics doesn't work very well for some things like economics, for example.
But if there's an ultimate reality, it has to explain economics, it has to explain insight, imagination, intuition, memory, love, compassion, goodness, truth, beauty, harmony, doesn't it, if it is ultimate?
Yes, and that makes me suspect that this is a little too much to be asking for.
I mean, I see mathematics as an alternate language that you can. There are some things I think it's most easily seen in quantum physics now. There are ideas in quantum physics that I think we all, quantum physicists at least, generally believe to be true, and yet are not simply expressible in common language that makes any sense. I mean, it just gets stranger and stranger the more you think about particles being in two different places at the same time, or two particles being entangled, all of these notions. But they're perfectly well expressible mathematically and easy to understand, not easy, but understandable by people who possess that tool. I personally believe that's where consciousness will eventually, if there is such a thing as consciousness, and if we get an explanation for it, it will not be a linguistic or descriptive explanation. It will require a kind of mathematics to express the weirdness that it actually is.
Let me go back to the two professors and come to you. Is there an observer-independent reality in your opinion?
Yeah, and I think we're just, as I said, we're enjoying it right now. This is the
observer-independent.
Yeah. It's I don't think anybody seriously thinks the jug of water on the table is dependent on you or dependent on me.
I think the shape of the jug, the color and texture depends on the nervous system. A different nervous system would perceive that totally differently. A honeybee would not experience that jug. A bat would experience that as the echo of ultrasound. A chameleon's eyeballs swivel on two different axes. I can't even remotely imagine what that would look like to a chameleon. So does that exist as a jug by itself?
Yeah.
I think we have to go back to the question of consciousness versus awareness. Many times we mix the two, and the problem becomes the linguistic problem, which, of course, Niels Bohr was very, very careful when he developed the Copenhagen interpretation, along with the other quantum physicists, pointed out to the importance of language, and that our language, which is steeped in classical world, cannot be transported to the quantum world. So there is an ultimate reality, but, and this is the big qualifier, it has to include consciousness awareness. I agree with Malcolm that it doesn't require human observers necessarily. Stuart was pointing the same thing. But I think consciousness is even beyond human observers. So the statement when I said yes at the very beginning, it exists because we exist, because consciousness exists. Ultimate reality is very much tied to consciousness. But not just human awareness. That is perhaps the product of 4.5 billion years of evolution on the Earth. So we're talking about a proto-consciousness, or a consciousness that is at the higher levels, if you like, that are more primitive and that don't necessarily require a human brain. So the entire biosphere is conscious. Cells are conscious. They have awareness. Dolphins can understand themselves or recognize themselves in a mirror. So from that point of view, there is an ultimate reality, but it's tied to observation.
So Stuart, this brings us to where you kind of talk about Planck scale space-time geometry as having basically the fundamental building blocks of both mind, matter, and mathematics. Would you speak to that a little?
Yeah, well, first of all, let me say about observer-independent reality, I misunderstood your question. I think I actually misunderstood my answer. But if everybody in this room closed their eyes and the cameras were turned off, the water picture would still be there. That's what. That's
as the water picture?
Well, as the water picture is now, we don't know that
Okay, this is a long argument. I think you cannot separate the observer and the observed. Anytime you try to do that, you get into a mess. The observer and the observed go together. They're part of one fundamental reality. And the reason I was asking you this question is you speak of it at Planck scale space-time geometry.
Well,
so
do
elaborate on that.
And I would have to disagree with what Menas said to some extent. What I think is intrinsic to the universe, built into the universe, is what I would call proto-consciousness, kind of like what's in our subconscious, perhaps in our dreaming consciousness, or what's in our minds before it collapses to a particular perception, reality, or choice or decision. So this proto-consciousness is a fundamental component of the universe, built in at the Planck scale, as are the precursors of all the particles, forces, as well as, I think, Platonic values, ethical values, and consciousness, the precursors of consciousness. But to become conscious...
And mathematical
truth. Yeah, Penrose clearly put mathematical truth as one of the Platonic values embedded in the universe, and then later added ethical and aesthetic values. So to convert these proto-conscious values into consciousness requires, in my view, in Penrose's view, a particular type of self-collapse of the wave function. And until that happens, we don't have perception. We have this sort of quantum subconscious or preconscious. But to have consciousness, in human consciousness or animal consciousness or even potentially in machine consciousness, you need a particular type of self-collapse. And that puts the superposition, which precedes the collapse, as a process, an actual separation in the universe in itself. It's actually a ripple in space-time geometry at the most basic level. That's the theory that Penrose and I have developed. And when that happens, when you have the self-collapse, bing, you have a moment of conscious awareness. And in our brains, it happens about 40 times a second with gamma synchrony, for example, or perhaps faster when you meditate. It seems to be more intense and so forth. So the precursors of consciousness are embedded in the universe, and consciousness happens at some point subsequent to that.
It's not continuous, is what you're saying.
No, discrete moments. Like a cinema, a film is actually made of discrete frames. We perceive it as continuous. Consciousness, and this goes back to William James, and many people have said that consciousness is a sequence of discrete events happening probably around 40 times a second, although the frequency can vary. And if it goes faster, the outside world seems to slow down.
Yeah, go ahead. No, go ahead, and then I want to bring
So I
these
guess what I'm missing somehow or another in all this is that I don't exactly understand why you have to go any further back than here to say there's consciousness. I don't see what it gets us to say that consciousness is an embodiment of the cosmos, the universe, of all of space and time. I don't know that it is or it isn't. I just don't understand what you gain by taking it any further back than this piece of meat up here.
Questions about identity, who you really are, and what's your role in the universe. Are you?
Well, but you may be fooling yourself about those things too.
We might be
really
fooling ourselves by thinking consciousness is here. Let me go back for a moment to the two physicists. Mm-hmm. Since you brought up Niels Bohr, here I have a quote from Niels Bohr. He says, "Everything we call real is made of things that cannot be regarded as real." Now, perhaps that's taken out of context, but that's a quote. Professor Alford, is a particle a physical entity, and if it is, what is it before it becomes a particle?
Okay. I just want to say something about Niels Bohr. He was famously hard to understand. So I wouldn't in any way blame you, for taking him out of context, because, even in context, it was not so easy to tell what he meant.
Maybe that was intentional.
Well, he and Einstein, as you know, argued for the rest till their dying day.
You're right. But to go to your thing about particles, if you're talking about particles that we see around us, little bits of dust or sand or something like that.
No, I'm talking about particles as the fundamental building blocks.
I'm on my way,
okay.
and it won't take long. Okay. Then of course these little chunks of stuff are real. Now, if you get to things like electrons kind of play different roles. In some sense, electrons are defined by the effect through which we see them. That on old-fashioned TV screens, which some of us older folk remember, that were not flat, and there were electrons being fired at the screen, and the way you could tell there were electrons hitting the screen was glowing in an interesting pattern. And so, if you said by electron I mean those things that, when you heat up a filament and put an electric field on, they come zipping out and make flashes on a screen. If by electrons you meant that, then of course they're real. If by electrons you meant something from the standard model of particle physics defined mathematically, expressed as a quantum of a hypothetical electron field that permeates the entire universe, then it's clearly theoretical. So, it plays this dual role, and it's very hard to say, whether it's one or the other, because it's both, depending on in what way you're talking about.
But we're talking of these particles as literally the fundamental building blocks of the entire universe, right? Including your body, your brain. And Stuart said that these come about as a collapse of waves or wave functions, and I think you would say the same thing. So my question is, what's a particle before the collapse? What is it?
Superposition.
It's a
Of
potential.
what?
Okay, let me go back. So Penrose addressed this. I think he's the only one who did it in various interpretations of quantum mechanics by saying, what is a superposition? What does it mean for a particle to be in two places at the same time? And others ignored it and just went on to calculate. But he said, going back to Einstein's general relativity, mass is essentially equivalent to curvature in space-time. So a particle over here is a curvature this way. A particle over here is a curvature this way. A particle in two places at the same time is a separation in space-time geometry at its most fundamental level, presumably the Planck scale geometry, and you have a separation in the universe. Now, if these were to continue, you'd have a branching, and you'd have two universes. And this is the multiple worlds hypothesis that says superpositions, there's no collapse. Each possibility goes on to form a whole new universe. You have the multiple worlds hypothesis.
I'm just asking a very basic question. I get all that, but what's a particle before it's a particle? And you said it's a superposition, and I'm just asking, and you further elaborated, superposition of curvature of space-time, possibly. Professor Alford, what's a particle before it's a particle?
Well, a particle...
Because we're talking about ultimate reality and this reality, too.
Right. So a particle, in the way you're talking about it, is part of a theory. Okay? And so when we're talking about our theory, we describe things in terms of it, and we do calculations and we make predictions. The particle... Well, you'll have to tell me more of its story, right? Where did this particular little iron nucleus come from? Maybe it was fired out of a supernova, a gazillion years ago, which is where, most of the heavy elements come from supernovas, and and so on. There's a history to it, right? But I don't think that's what you mean by before, right? You mean some other sense of before.
Yeah, I mean, is it a possibility or a potential in some transcendent?
Well, okay, all right. So if you want something that's got a bit more sort of transcendent oomph to it, then it's true that the current theory of particle physics envisages the world as having these fields everywhere. There's an electron field, there are quark fields, there are neutrino fields that exist everywhere, and what we call particles are just quantized vibrations of those fields. Okay? And you can take that and build all sorts of exciting metaphysics on it, but it's a theory, although it works very well.
You're a theoretical physicist,
That's
right?
the name.
Menas.
Let me try to put a little bit of a spin, no pun intended here, but talking about quantum particles. To just get straight to your question, particles are potentia in Heisenberg's work. They are possibilities of existence that, under the right circumstances, bringing in the observation and the observer into the picture, take on specific values that we measure in the laboratory. So the observer and the observed is a very, very important component of quantum theory. And it is completely different than classical physics. We have to say that the traditional way of looking at the universe, where there is the reality out there, and we, the observers, are passive observers of like a movie going on, it's out of the window. Quantum theory has shown that the observed complementarity is very, very crucial. Now, again, back to the question of awareness versus consciousness. I think actually we agree more, Stuart, than you said before. I agree with you. There is a fundamental what you call proto-consciousness. I call it just consciousness. It's distinct from human awareness. Human awareness is a product of evolution, et cetera, et cetera. The collapse that we're talking about, of this potentia, field of potentia, down to specific values, has to take place with an interaction with an observer. The question whether the tree makes a sound when it falls in the forest, or as Einstein called it, is the moon there when nobody's looking at it, is immaterial, because we cannot extract consciousness from the act of observation, from what we're observing. We sort of believe that it's reasonable that we all share a certain reality with capital R. What that reality is has to be contextual, and it has to be brought into the picture of what we're observing. So there is an ultimate reality, but it does contain us as active participants.
Thank you. I want to bring in Professor Firestein into the conversation. He's a neuroscientist who believes, I think, that consciousness is here, but that's
It's a bet. Reasonable bet.
a reasonable presumption, like any other. I'm quoting here some Penrose, a quote, and I'd like your comment on this. It is mathematically impossible for a physical system, brain, or computer to process meaning. Any comment?
Read that again.
It is mathematically impossible for a physical system, if you think of the brain as a physical system or a computer-like system, Penrose says it's mathematically impossible for a brain or a computer to process meaning, because this has many implications. If we are thinking of the brain as a purely physical system, then we deny ourselves true creativity, free will, choice, meaning, purpose. What's your take on that?
Well, the statement, I guess, is a sort of a Gödelian kind of formulation of the brain, right? I mean, that there's a self-limitation within the system to in fact, perceive itself in this particular case, rather than, let's say, prove itself. I'm not really sure where I stand on that. I mean, in some ways, I think we're a little too enamored with our consciousness. I'm not even convinced such a thing really exists.
I'm talking to a conscious being.
Well, yes, but in this more metaphysical way of a consciousness, I shouldn't say metaphysical way, in a less metaphysical way of consciousness. That is, as if it were something we could hunt down, as if it were something we could figure out, as if it were something that would show up on an fMRI. I'm not sure I believe any of that. I'm not sure. It's one of those questions that the famous thing in physics was, it's not even wrong, the idea of consciousness. So I'm not sure the question holds tremendous validity. But I guess for the purposes of our discussion today, it's better to avoid that. I would say that there are limitations in what we might be able to do. We have a phrase that I'm always fond of, is one from a historian of science named Nicholas Rescher. He's at the University of Pittsburgh, and he talks about a cognitive Copernicanism, or Copernican cognitivism. Well, whichever way, it's the same thing. I mean, in which he points out that the Copernican worldview has moved us off the center of things. We have no privileged place in the Copernican worldview. We live on a little ball of dirt and way out in the midst of nowhere in a galaxy that's also way out in the midst of nowhere, and so forth. And that we may not have any more privileged a cognitive landscape than the physical landscape we live in. It just feels that way. I don't know, maybe that just takes us around in circles somehow.
It doesn't.
Or
I think what we're here to talk about really is, can science give us a clue to ultimate reality? And that's why we're here as biologists, as a physician who's also very steeped with Sir Roger Penrose in the understanding of Planck scale geometry, as physicists. Another question. So, we're in fact maybe in a way questioning whether science has the ability to do that. So here's a quote from Niels Bohr again. And I'd
Can I
like...
respond to something Stuart said?
Sure.
Because with all due respect to neuroscientists, and I deal with a lot of neuroscientists, they tend to kind of explain away the problem. Consciousness, it's, well, I'm not really sure it exists, and blah, blah, blah. And I think, of course it exists. And I think the reason is, and I'm not picking on you because I've dealt with many neuroscientists and philosophers. Dan Dennett started started this by explaining away consciousness. And neuroscientists have certain tools, fMRIs, electrophysiology, et cetera, They do all this stuff. We know a lot about the brain, but consciousness is missing. Therefore, the response is, well, let's just get rid of it. It doesn't really exist.
No. So I agree with you. That is a bankrupt way to think. Just, that's that sort of Skinnerian ultimate reductionism, which I would not participate in particularly. I just think that when you're talking about the brain and how it works and things that we think the brain does, such as consciousness, you believe maybe it's beyond the brain. I just think we're extremely bad at judging what it is that's difficult for a brain to do or what it is that it's easy for a brain to do. We've gone down many, many false roads in brain research, and the problem is that we're very bad at reporting on it ourselves. We have relatively limited access to what's going on. You're never going to learn about the brain, in my opinion, by pure introspection. I mean, you can introspect all you want, and you're not going to figure out, at least from a plumbing point of view, how the thing works.
You're not going to learn about the brain, you said. By introspection, yes.
Now, you may learn about some of its emergent qualities, if you will, or things that it produces.
Yes, I would like to say, if you're examining consciousness, it's your consciousness that's looking at consciousness, and by definition, that's a subjective experience. Any objective validation of consciousness is at best inferential. It's not direct. And, you can throw this off as, no, Stuart may not say that, but I'm saying it. I'm really trying to hone in on the limitations of science. And I want you to comment on that because I've seen you in the past talk about limitations in science. So here's a quote again. What we observe is not nature itself, but nature exposed to our method of questioning. Niels Bohr. From another contemporary of yours, John Wheeler. In the beginning, there were only possibilities. The universe could only come into existence if someone observed it. It does not matter that the observers turned up several billion years later. The universe exists because we are aware of it. Now, without really spending too much time, can you, each of you, comment for a minute? You want to take a crack?
I would say that Niels Bohr and John Archibald Wheeler are absolutely correct. What they're talking about is an observer, participatory universe. And as such, the question of existence of reality without bringing in consciousness gets us into infinite loops that we cannot get out. I think that's what you're bringing up. Can it be known externally as an objective reality? I believe it can be experienced, but it cannot be known as an objective reality because consciousness, by definition, ultimately is subjective. And I'm not talking about just human awareness, but I'm talking about the ultimate consciousness beyond even the Planck length. So the answer is yes, there is a reality, but it includes the act of observation in a fundamental way, and this is a big difference between the classical world and the quantum world.
Professor.
Okay, I think both those physicists, I would interpret them as speaking maybe poetically about the kind of feelings that their theories give them about the universe. You look at the universe, you do measurements, you develop theories, you try to get the theories to fit the way the world behaves, and whether you should then take the theory that works very well and treat it as this sort of final truth is, well, I have my doubts about that. Mm-hmm. And so I do think that science is not a way of getting to ultimate truth. Science is always a way of getting reliable knowledge, not ultimate truth. And reliable knowledge is very useful.
Nobody questions.
Right, nobody questions that. Ultimate truth, that's a much harder thing.
2 points. Bohr observed dependent reality, put consciousness outside of science, causing collapse to create perceived reality. And that worked, allowed them to do pragmatically to do experiments, but put consciousnose outside of science. Penrose put consciousness as the collapse, and also Henry Stapp.
Conscious awareness.
Conscious awareness, yes, as opposed to what I call, we have a semantic issue here.
Semantic.
But conscious awareness, what I as an anesthesiologist want to get rid of and keep away until the surgery's over.
Okay.
Get rid of it. So Bohr put consciousness outside of science. Penrose put consciousness right on the collapse. A particular type of collapse is consciousness. And one other point, Stuart, you mentioned, you said that I'm saying consciousness beyond the brain. Actually, the space-time geometry is in the brain. It's between the ears. It's around the microtubules, inside the neurons. And under normal conditions, it stays there. So I'm not necessarily going beyond the brain. The brain is made of space-time geometry in some sense.
Let's switch the subject just a little bit, because these are words that are now so much part of our language, and culturally it's becoming fashionable to use these words in different contexts, and the physicists get really upset and the biologists get upset. So let's clarify that, some words, and take a minute or two to explain. Non-locality.
Okay. So non-locality comes in different types, and the traditional type was action at a distance, where something here affects something over there without going through anything in between. And that really doesn't exist in physics as far as we can tell. It's now more expressed in terms of nothing can go faster than the speed of light. That's kind of the modern version of it. And we've never found any indication of information or energy traveling faster than the speed of light. So there's very strong evidence for locality in that sense. Now, quantum mechanics contains a different form of something that one could call non-locality, arising from entanglement, and there's various things that go along with this, the Einstein-Podolsky-Rosen experiment and all this sort of thing, which are central to what people have been talking about here. And there you do get this very strange thing where you separate two objects, and you find that you do a measurement on one of them, and that it's very hard to say it right, but you find there are correlations between the results of measurements on one and the results of measurements on the other. And these correlations either require that the system, so to speak, and don't take me to the bank on this one, but so to speak, didn't make up its mind what result it was going to give until you did the measurement. Or it would require information to go faster than light from one to the other. Okay? And it's not action at a distance. Abner Shimony called it passion at a distance, which I think is a very lovely way of describing it.
Einstein, spooky action.
Yeah, well, so Einstein, I think, didn't yet have this distinction. He sensed that there was something non-local in quantum mechanics, and he was worried it was the first kind of non-locality I was talking about, where actual energy or information goes faster than light.
So just coming back to this...
But it isn't.
Okay, it's correlation though, right?
There's some sort of correlation there. And you can't send a message.
And the observer is very much part of this correlation, because it's the choice of the observer to measure whatever, spin, charge, position, momentum.
Yes, although I would say an observer could, in principle, just be an observing instrument. Doesn't have
prosthesis of the human observer.
Okay. So anyway, I guess I'll stop, because you guys probably both want to put your own spin on what I just described.
You want the same on non-locality?
Yeah.
Yes, very much what we just said. It's you cannot send information. You cannot use it as a coding or decoding algorithm to send information to submarines, etc., etc. But it is non-local in the sense that what happens on one side and what happens to the other side, that could be at the edge of the universe, billions of light years away, the two particles are correlated. But if you just look at one, you won't be able to make a sense, because it's random noise. If you look at the other one by itself, it's random noise. It's when you bring the two together, there are these spooky correlations.
I'm asking a more deeper question. Yeah. You, as the observer, or the instrument as the observer, decides what to measure here and immediately determines the measurement there.
Absolutely.
So I'm coming back to, is there a role for consciousness here?
The observation, let's not bring consciousness yet, because it's a loaded term. But the observation itself, the observation that you perform on one side, tells the other side, quote unquote, what values to assume according to the rules of quantum theory. But you cannot use it to send information. That's what you were saying.
Correct. Stuart, what's the relationship between quantum entanglement, and feel free to argue and object, quantum entanglement, non-locality, and quantum biology?
Right. Well,
let's make it simple for everyone.
Right. Thanks. Well, non-locality and entanglement. I think Admiral Shimoni's description was beautiful. Passion at a distance. It points out the difference between information between here and here versus feelings, awareness, whatever it is, between here and here. Now, with causing the spin up, spin down, I'd have to think about that. But I think there's entanglement in the brain. I think that's how we have binding. I think that's how we have even synchrony at high frequencies. I think it's how we do quantum computing. And I think non-locality is part of that. And by the way, the Penrose explanation, which was also put forth by Ben Schumacher at about the same time, if you make a measurement here, it's not necessarily faster than light. It's even more bizarre. It goes backwards in time to the origin when they were together, and then out on this limb. And we know from Wheeler's delayed choice experiment, also from Libet's experiments in the brain, that there can be backward time effects. So I think when you get to non-locality and entanglement, you have to consider non-locality in time. And there's more and more evidence that that backward time effects occur in the brain.
Stuart, one of the big problems in neuroscience, as I believe it, what we call the hard problem, is the relationship between subjective experience and what happens in the brain. As far as I know, there's not even a theoretical framework to explain that. But the other thing is binding, right? Disparate parts of the brain, phase and frequency lock in, and our perception, our cognition, our moods, emotions are somehow all kind of correlated. And I'm just wondering if the next frontier in quantum biology will begin to explain things like binding, begin to explain things like morphogenesis and differentiation, how a single cell multiplies by itself 50 times, becomes the 100 trillion cells, which is almost more than all the stars in the Milky Way galaxy. And they're all kind of keeping track of each other without sending messages to each other. How does any organism function as an integrated whole, not just the brain, but the whole body? How does the human body think thoughts and play a piano and kill germs and remove toxins and make a baby all at the same time, while it's correlating its biological rhythms of the symphony of the universe? Now, as somebody who's not anymore in academia and can go far out and sort of totally out of the box, I would like to suggest that quantum entanglement, quantum biology, binding, morphogenesis, differentiation, self-regulation, the correlation of various feedback loops that result in homeostasis is an example of a non-local mind, actually. And that non-local mind is omnipresent, omniscient, omnipotent, and you can call it whatever mathematics you want to apply to it.
Okay. What's a non-local mind?
Mind beyond space and time.
Mind, just to pose the question, what is beyond the Planck scale where space-time arises? By definition, already talks or thinks outside of space and time. So in terms of going back to the fundamental issue of consciousness beyond space and time, it's got to be beyond the Planck scale, and it's got to be at a very, very fundamental level, out of which space and time arises. We don't have a theory of it yet, but we know that space and time is not fundamental. Space and time is fundamental if you're talking about particles moving in trajectories in dynamical systems, which we can do very well with second-order partial differential equations. But that's not the entire story. There's nonlinear effects perhaps in the brain, and this is actually where maybe quantum theory will reach an end, that cannot be explained by quantum mechanics, because current quantum theory is really linear theory.
Can I say something? So this is extremely contentious, as you can probably imagine, that, there are big arguments about this, and the reason is that this funny sort of non-locality, the Partial interdistance kind of weird quantum mechanical non-locality, is usually very delicate. It's very difficult to arrange it. It took enormous effort for experimental physicists to set up the experiments necessary to show that this happened over long distances. It was only really done in the last 20 years or so. So the suggestion that these very delicate processes are the crucial feature of the functioning of the human brain, which is your main point, is something that a lot of people disagree with. It's fair to say. I think this is no secret,
Quite aware,
right? A lot of physicists, most physicists, I think that it's not a suitable environment where that sort of thing can happen, and that it's more likely that consciousness arises from other, more conventional bits of science, and you don't need to reach all the way to the most exotic, the most delicate, the most bizarre bit of modern physics. You don't need to reach all that way. That there's plenty of powerful phenomena available that could do it by more conventional means.
No theoretical model that explains.
No. Nobody's trying. I'm saying that there's no need to go that far in the effort. No one's saying that it's been done. It hasn't been done. What you're asking is, what kind of ingredients do you think are going to be needed? Okay, and maybe you need these sort of super duper, the most exotic stuff, but maybe not.
Okay. I think it might be appropriate, because we're kind of getting carried away in our own world right now, to invite questions from the audience and see what you feel, whether this discussion has been at all useful to you, or it's just who cares? But
or both of those.
You're free to ask questions of any person in the audience. And
there's a question. Let us know who you are, too.
Yes.
Lois Oppenheim, and I come at this from the humanities. I know very little about the hard sciences. I'm curious about your distinction between consciousness and I don't think you named what would not be consciousness. So I assume you're talking about consciousness and non-consciousness.
I bring a very Eastern, as Alford would say, metaphysical perspective. So here's how it's defined in the East. Okay, that which cannot be imagined, but without which there is no imagination. That which cannot be perceived, but without which there is no perception. That which cannot be conceptualized, but without which there is no thought. So everything that we call reality, whether it's perception, cognition, moods and emotions, personal relationships, social interactions, and environment, are differentiated, entangled, I didn't say quantum entangled processes of consciousness. In other words, in this worldview, there is nothing other than consciousness.
Okay.
And here I use consciousness and soul and spirit and intelligence synonymously.
That leads me to the rest of my question, which is the following. Does that rule out the possibility of levels of consciousness?
It does not. We already know 3 levels: waking, dreaming, and sleeping. And if you go deeper into the Eastern metaphysical traditions, there's soul consciousness, there's non-local consciousness, there's divine consciousness, there's unity consciousness.
Is there such a thing as unconscious? Is there such a thing as pre-conscious? Is there such a thing as pre-reflexive?
These are Western terms that find a place here. What you call the unconscious or pre-conscious is the supraconscious in other traditions, because it's monitoring the activity of the total universe, non-locally.
And how would
I was saying the description sounds like Freud's primary process.
Very much.
They're talking about something outside of
Space-time.
space-time.
Outside space-time.
And I wonder whether...
Actually, I'm sort of quite sympathetic to the idea of constructing these sorts of sort of patterns of ideas that you're talking about. I just think that you don't need to, as I would think of it, contaminate them with stuff from science like quantum mechanics and things like that. Because quantum mechanics and all the sort of science that we do now is, early 21st century physics. And as was pointed out, late 19th century physics, if you try to do the same thing then, you'd be talking about, it's the ether. Well, oops. There is no ether, right? That got dropped. And other things have gotten dropped along the way, phlogiston and all sorts of things. And if you rely too much on the current scientific paradigm, wait 100 years, it's been replaced. So I don't think you want to be using it as a foundation. You can use it as inspiration. You can use it, in various ways. But I don't think you want to actually build on it like it's the foundation. I think you actually can have your own.
Stuart would disagree with that.
Yes, I would. I think there are definitely levels of consciousness, including the Freudian levels and so forth, and there could be non-conscious processes. But for example, let's say we're having normal consciousness with 40 conscious moments per second. We know that the monks that the Dalai Lama selected and sent over to University of Wisconsin to be studied went to 80 conscious moments per second. So in an enhanced enlightened state, we'll call it, or just an enhanced state, a higher state. They had more conscious moments. It's kind of like shifting to a higher level of the electromagnetic spectrum, higher intensity, higher frequency, which means the perceived world slows down. And it's also possible that you can actually shift to even higher frequencies, going smaller in scale inside the brain, to multiple levels that could even, Deepak and I have discussed the possibility of even astral plane type levels of consciousness existing by going deeper into the universe, smaller and smaller levels, higher frequency, all occurring within the brain, perhaps also outside the brain. But
see, the problem, I recognize totally, his reluctance to say, don't use science because you have a model by itself. On the other hand, when we say science and ultimate reality, which is what we're talking about here, and you talk to unified field theorists or string theorists or whatever, they'll only talk about gravity and strong and weak interactions and electromagnetic activity, which basically, for most of us, other than the fact that we watch TV and use transistors, is irrelevant. We want to know, how does this unified field, which is the source of everything in the total universe, explain how I feel, explain compassion or love or my connection to you or meaning and purpose. So which brings me to a very simple question right now, and just say yes or no. Is the universe purpose-driven, Dr. Alford?
Okay, I'll say no, since you want me to say yes. But what I really want to say is that I don't think that's a very good question. I mean, it's a dangerous question.
Is consciousness an emergent property of evolution, or does it drive evolution?
It seems more likely that it's an emergent property of evolution, just because as you look at organisms along the trail of evolution, it seems like consciousness becomes present in
where?
More.
That's the question. Where?
Anywhere. Where what?
At what level?
Well,
is a worm conscious?
Well, so what I'm saying is that it seems like you're conscious. Dogs, they seem conscious. They have feelings. You can hurt a dog's feelings. But right, when you get down to paramecium and worms and bacteria, it becomes harder and harder to see them as being conscious. So it does seem like it's emerging.
In that context, I have a question.
Oh.
My name is Natalie Rogers. How do you think the feminine brain should evolve before it can be capable of discussing ultimate reality?
Before it can become?
Capable of discussing ultimate reality.
You are a brave man.
I know.
I'll take it on too.
Yeah, well.
It's all yours.
Okay. What I was going to say is there's a female astrophysicist in Italy, Paola Zizi, who has done some amazing work in quantum physics and cosmology. She has a theory of consciousness in the early universe during the inflationary period of the Big Bang. She used Penrose's equation for consciousness and used the mass of the universe as the superposition, and showed that the timing for self-collapse for the universe exactly coincided with the end of inflation during the Big Bang, implying that the universe at that instant had a cosmic conscious moment during the Big Bang, and it's been dubbed the Big Wow theory. So, and that our consciousnesses are literally microcosms of that original consciousness. Now, it's obviously a controversial theory. The point is that there's a female brain who does comprehend it. So I don't think you have to evolve any further. Maybe just,
So we would have to go all the way to Italy before we found a woman who was capable of engaging in
I'm just
this
giving you one
discussion.
example to prove the point.
I think the female brain at this moment in evolution is ahead of the masculine brain, which was part of the Darwinian evolution of what we might call survival of the fittest. We became the predator on this planet. So what Jonas Salk has said very eloquently is that the next phase of our evolution is what he called metabiological evolution, which is beyond our biology, the evolution of our consciousness, and then ultimately the evolution of the consciousness of our consciousness. And for this we require the feminine brain, which has a sense of aesthetics, of nurturing, of beauty, of intuition, of affection, of tenderness, and of love.
But obviously, I haven't made the point, and the point is there's no representation here.
But that's easy to explain, actually.
Can you explain that?
Am I not?
Go ahead.
Am I not replacing a female? Oh, it was not a female.
No.
I wasn't sure of that. No. I was a late replacement for somebody who came down with
That question you should ask Edward.
So then you got to ask these. You got to ask these two old guys. These two old white guys over here will tell you why.
Variables. It's not that we don't at every roundtable try to get our goal at the center to make sure that we have women at every roundtable. And sometimes we've had roundtables where it's been all women. But sometimes it's not possible. There's people have to be willing to come here. In fact, there was one woman who was scheduled to come who couldn't come because we didn't have the funds and she couldn't come.
Right.
So, but it's not true that we exclude in any way women from the roundtable.
Well, I will try to accept that answer. It is strange.
I appreciate
Yes.
it.
We have another question right over here. Let us know who you are, actually.
Stuart. Hi, how are you? Good to see you again.
Hi, Stuart.
Physiological psychologist, and I hate having to stoop for it.
Because you're too tall.
Yeah,
That's
we went through this last time. So a couple of points from our astrophysicist, and then relating one of them to yourself. In terms of the fragility of entangled particles, last week it was done, I think, at Princeton, that 10 billion particle pairs were entangled, embedded in silicon, and remained stable. So not so fragile anymore, perhaps.
What temperature? Was it cold?
It was. I'm getting to the 180K on something else, but no, it wasn't needing to be approaching absolute zero. It wasn't that cold. The second one is the question of the need to look at quantum processes in this discussion. I just want to bring up research that was published almost a year ago today at the University of Toronto that certain cryptophyte marine algae rely on in using protein-based photosynthesis, kind of a rhodopsin. They rely on photonic superposition and collapse for the photon to travel through the molecular structure with the highest conversion ratio. Yeah. And not only has that been replicated, but the different species within that genera have evolved slightly different molecular structures to accommodate the superposition collapse. So it's important. And that was related to your question that didn't really get addressed that much about quantum biology.
Yeah, and again, that's one example, but the other photosynthesis, bird navigation is being brought up as another example. Third example is ionic ion channels. So in microtubules, I think once you have the question, then we'll start looking at the various ways to approach this. I can't think how biological organisms can function as an integrated whole, or if in fact the ecosystem function as an integrated whole without that possibility.
And I'm happy to hear it, which is why I just wanted to throw in some research to substantiate that.
And it's absolutely, I mean, what you're saying is absolutely correct, that you cannot just do it by classical systems.
Absolutely.
And one big debate that's going on is, the intelligent design and all of that. But in fact, the evolution of the universe or the evolution of the biosphere could not proceed, I believe, without quantum effects, because they accelerate things much more. You pick paths because of this potential that collapses into specific pathways. And therefore, quantum biology will have to be integrated. Now, I also agree that it's not going to be the end of it. We'll have to go beyond even quantum theory. But at least it has opened the door. Quantum theory has opened the door in a very, very fundamental way, which is totally different than classical physics.
So, for sure. It's a very, and there's also a Kuhnian.
So there's, of course, there are quantum coherent effects. Every atom is a quantum coherent thing. The reason it doesn't collapse, as classical physics would predict, is to do with quantum coherence of the electron in the atom with itself, so to speak. So there is quantum coherence in various different places. What's striking about the results with photosynthesis or stuff like this is that you're finding a little bit of quantum coherence in a place where otherwise there's very little. Okay? And so, of course, we shouldn't rule out quantum coherent processes as things that may play an important role, but neither should they become this sort of universal solution where you go jumping at them for everything when there may be other mechanisms.
Good point, with the exception that occurs at 180K, and as far as can be told so far, their evolutionary success was completely dependent on this. So it may not be, to apply a metaphysical quantum explanation where it's not necessarily deserved, it is to be avoided. But I think the actual physical underpinnings of, like, for example, some of the things Dr. Hameroff was talking about are we're gaining evidence for those. And thank you for taking my observation.
Use of the term quantum biology to describe these things. This is quantum chemistry. There's nothing wrong with that. Quantum chemistry exists everywhere. It's just fine. I mean, that's what photosynthesis is, that a biological organism through evolution has picked up on the ability to do that is no different than the way it's picked up on doing enzymatic chemistry or other kinds of catalytic chemistry. I don't see anything special about the fact that it's made use of quantum chemistry.
What's special about it is two things. One, mostly that it occurred in a living organism and at 180K.
And all life depends on it.
I'm talking about photosynthesis. Photosynthesis doesn't. Photosynthesis is, in my opinion, very simple, but it's a kind of quantum chemistry, and there's nothing special about it or wildly explanatory or universally explanatory about it.
But it is quantum. It is quantum.
Well, absolutely, but it's no. To me, it's no more remarkable than evolution having hit on catalytic chemistry.
Let's call it quantum biochemistry. Will you be happy with that? Quantum biochemistry.
Why can't we all just get along?
I just don't think that it explains. It's not an explanatory. It doesn't explain biology. It doesn't overarch biology any more than catalytic chemistry does, or enzymatic chemistry, or any of those other kinds of biochemistries that we would, none of us here would be saying.
Well, that remains.
In fact, most of us here would object to saying that we can explain consciousness by invoking biochemistry or catalytic chemistry. So I don't think we should invoke quantum chemistry to do it either.
Well, but we also have to not eschew levels of scale at every point in discussions like this. And emergence was brought up several times. Of course, a chaotic boundary. When you have an emergent phenomena, you can't predict it. We know the classic examples from the initial starting conditions of the pre-boundary traversal state. So there's a lot more going on, but as long as you carefully differentiate the level of scale at which you're addressing.
Deepak, can I just ask one question?
Yes.
What you said before, are you, for the lay observer, and this is way beyond me right now, are you talking about non-materialistic view of consciousness? In other words, are you basically saying, when you said consciousness is not an emergent from evolution, but are you suggesting that consciousness pre-exists evolution?
I'm suggesting that matter is an illusion and consciousness is the reality.
It's a non-materialistic view of consciousness.
Thank you all so much.
Thank you.
This is sort of like a simple question about, this is going back to the Greek idea of how you connect this today with science, about cosmos equaling order, pattern, and particularly the sensibility of beauty as being maybe a conscious energy. If you have any thoughts about that, I'd appreciate it.
I think Stuart, when he mentioned mathematical truth, Platonic values, which are truth, goodness, beauty, evolution, harmony, and the fundamental building blocks, he was talking about that. He was addressing your question, which actually brings to mind another quote from David Bohm this time. It says, in some sense, man is a microcosm of the universe, therefore what man is a clue to the universe. We are enfolded in the universe. That's David Bohm. It's been a while since I heard of holographic theories. Would you address anyone the holographic universe?
Well, the holographic universe actually comes out in the particle physics from the observation that in certain Bekenstein particularly, you can assign information to one bit of information to every volume of Planck cell, and therefore then you can map the amount of information that exists in the universe. You can do a transformation, and you can sort of count. It's not uncountable. It's a very large number, but you can count the bits of information that the universe contains. And it turns out that when you do that, you find that there are certain scale invariant relationships. In other words, relationships which apply at every level. So that actually sort of reminds us of a hologram, because a hologram, the part contains information about the whole, even though it's not as sharp. In a hologram, if you cut a little bit of a hologram and you project that, you don't get as sharp image as you get if you have the entire thing, but you still get most of the useful information. So from that point of view, it seems to be very exciting. We're not sure if that's going to turn out to be the case. But going back to the metaphysical aspects of these, there is a particular saying that a sutra that says, "As here, so elsewhere," or "as above, so below." So it's very, very interesting to look at the human brain, for example, and see if there are patterns there that are scale invariant, that take place from the nanoscale all the way to the size of the brain and beyond. And if that is the case, then you would have scale invariance biology, as we suspect it may happen in physics.
And I think we have that. Actually, Marcus Rakel, talking about default networks, has published that there's scale-free dynamics in the brain from the level of train of thought down to the level of EEG frequencies and below. And then if you get to the microtubules, if you go every 2 or 3 orders of magnitude, you go down and down and down. And that could also hook up to fluctuations in the universe that come from the Planck scale that have been detected with the quantum gravity or with the gravity wave detector in Germany. So it's possible that we have this scale-free dynamics from the Planck scale all the way up to biomolecular processes in the brain and then into conscious thought. So, and of course, Pribram had this idea about the holographic mind and Lashley's memory and so forth. And I think all of that is quite valid and probably should make a comeback. Well, but the ideas are going to go on,
The idea is actually ancient. In the Vedantic literature, there's yatha pinde tatha brahmande. As is the universe, so is the atom. As is the microcosm, so is the macrocosm. As is the human body, the cosmic body. The human mind, the cosmic mind. So it's an ancient idea, actually. Any other questions?
There's another ancient idea that phylogeny.
Yes, phylogeny and ontogeny. Go ahead.
It's completely wrong. I just want to point that out. It's a completely bankrupt idea. And so we have to be careful that some of these ideas that have an attractiveness to them because they look right, they seem right, they fit a kind of a good feeling about things that we might have. But they're wrong. Phylogeny does not recapitulate, ontogeny does not recapitulate phylogeny. This is an old idea. It's stuck around. There are many people in this room, I'm sure, have heard it and believe it because it's been said so many times. It's simply not true.
Well,
it's an idea of an old German
evolution remembers its past experience. I mean, 65% of your DNA is the same as a banana. And that is because once nature figured out how to make a banana, it said, I'll make other things with it.
Yes, but I don't think that's a... You'll pardon me for saying this. I don't think that's a deep statement in the way you mean it.
Well, I don't
mean to be quite so blunt.
No,
but
it's all right.
I don't mean it bluntly that way. I just don't mean that I don't think
it just happens that my name is Deepak.
We have 2 questions. Do you want to go first?
Very good.
Could you introduce yourself?
I wanted to ask Deepak Chopra a question, and I come from a background. I work in the arts, and this whole discussion has been actually very difficult to follow. Simply don't have the background. So I'm coming back to your very first question about an ultimate reality and the idea of an uncreated moment before creation. And I'm not understanding why it seems to me a somewhat static conception, and I'm wondering whether or not the ultimate reality can't be dynamic and can't be a process, and you can never back up behind that process. And in fact, what so many of the speakers are talking about, that the paradigm will change every 50 years, every 100 years, isn't that following along behind that kind of ultimate process, ultimate evolution, as against an ultimate reality that stands in a static form behind it all?
Very, very beautifully stated. In fact, there is nothing other than process, and the only ultimate reality that would not be a process is the potential for that process. And then I was being a little careful, not using the word God. That's all.
One big thing left out.
Hi, I'm Randolph Horner. Please, this distinguished gathering, don't think that I'm being reductionist in thinking only about the peril of a chemical situation in our atmosphere, but allow me to note that the climate catastrophe that has overtaken us is a metaphor for our somehow getting disconnected from a cosmic reality. And my question here at the end of this gathering is, beyond the metaphor, how can our consciousness be so impervious to the cries of many, many trillions of components of reality that are telling us something is very badly wrong?
Deepak.
Yeah. Go ahead. I'd like to address that.
You're absolutely right, totally right. And in fact, even though I'm basically an optimistic person, I do hold a little bit of concern for the survival, not just of our species. I mean, we know that there's many more insects than there are us. You know, in fact, if you add up all the mass, all the weight of all the insects, it's more than a human weight. Put them all together, so it's amazing. You know, right now the Earth is dominated by insects. It's not dominated by humans. But of course, we are doing something very dramatically wrong to the environment. I totally agree with you. And it is because of that disconnectedness, perhaps from creativity, from art, and from the deep human values that are very much part of us. And I think going too much into the scientific world has that big peril. It's a big issue, and I think Western science needs to wake up and address these issues, because our very survival, and perhaps the survival of the Earth, is at stake here.
I would go further and say that the scientific method itself and the basis of science itself is, in a sense, intellectually dishonest, because we separate the mind from the body. We separate the biological organism from the environment. We say, that's the environment, that's me. Well, those trees are your lungs. Right. If you didn't breathe, they wouldn't breathe, and they didn't breathe, you wouldn't breathe. The rivers and waters are your circulation. The earth is recycling as your flesh and blood. The atmosphere is your breath. So this schism that we have as a result of what became the Newtonian worldview and the Renaissance in science is, separating organism from environment, genes from epigenes. It's one process. It's a single unified process. And therefore, till we reinvent a science that gives as much value to subjectivity as it does to objectivity, and as much value to the process as was mentioned, our science is the very basis of all the diabolical, great things also, but some very diabolical technologies as well.
Can I say something?
Yeah, please.
So I think this, okay, in order to understand things, you have to make some simplifying assumptions, and it's very often helpful to find the right way of breaking things up and considering parts in isolation. But as I was saying before, you mustn't lose sight of the fact that you made an approximation. You've got a theory, you've got an approach that gives you reliable information about this thing. You do not have a final ultimate picture of it when you have one of these good theories. And thinking that you do may indeed lead to thinking that it really is broken up in pieces the way you broke it up in your theory in order to make progress on understanding it. So I agree this is a possible pathology, a possible, bad turn that science can take. But maybe as a scientist, I think that if you do your science in a slightly humbler way, you can get the benefits of science where you make the right sort of simplifying assumptions without then imposing those assumptions on the world as a kind of judgment.
I totally agree with you, but I would ask you a question. Do parts really exist, or are parts patterns of behavior of the whole?
Well,
because it comes back to the fundamental question. Is there process or is there structure? Are there any structures in the world anyway? Or is it all a impermanent pattern of behavior of the whole?
Then how do we make deductions, and how do we have verifiability? How do we make any... I'm dependent on you then.
As he said, approximations, and as long as we have that humility, we do. I mean, he's very precise.
But that's the use of the scientific process.
That absolutely is.
Engineer whose
absolutely
name,
is.
He slips, and you may remember it said, all models are wrong, but some are useful.
Mm-hmm.
And I think that's the way
very
we
well
have to
said.
use them, right?
Sure.
Yes.
Absolutely.
Yeah.
There's a dynamical the reality there, and the dynamical process. It's a dynamical thing that changes. I wanted to just answer a little bit or bring up the issue because you said that these are maybe left brain or guys talking about the science, and I don't understand the art part. Einstein came up with the general theory of relativity. One of the many, many possibilities based on its elegance and simplicity. He said very simply, why did you choose, Albert, why did you choose this tensor theory, which is very, very complicated? And he said, well, because ultimately it is the simplest and the most elegant theory. And he said, if God had to create all of this, he would have to pick this because it's the most elegant. So Einstein, for sure, was going into theoretical ideas that were elegant, they were beautiful, and they were really much more artistic than you would say than the left brain way we assign to science.
That's not true for biology, by the way.
Well, that's why biologists are behind times.
Actually, it's not always true in physics. I mean, sometimes it's true in physics that beautiful theories are the best ones, but there are some examples, like the fact that the parity symmetry is violated, which nobody could believe. How can physics in the mirror be different from physics not in the mirror? It's ridiculous. They can't be different. Right. It's an obvious symmetry nature ought to have if it has any claim to any kind of beauty and symmetry. Well, it doesn't.
Yeah, but it broke down.
Yeah.
Any questions from the audience? As you're coming up, may I ask a question of our physicists, and you're free to participate. Any implications of Gödel's theorem in your mind that give you a different worldview?
Well,
yes.
Yes. Roger Penrose wrote The Emperor's New Mind in 1989, which is kind of a slap in the face of AI, artificial intelligence, which is arguing that the brain is a computer and consciousness is an algorithm. And he pointed out that, according to Gödel's theorem, that you have to be outside the system to understand it, to have meaning and purpose. And as a source of, he called it, you needed something non-computable. And as a source of this non-computability, he put forth this idea of a particular type of quantum collapse of the wave function, objective reduction, and due to an intrinsic threshold implicit in the universe. So that made the connection between brain processes supporting consciousness to the fundamental level of the universe. So yes, there's a need for Gödel's theorem in explaining the mind.
There's definitely a need for Gödel's theorem. I would say most physicists ignore it, or they say, well, we don't. It's not really relevant. Very briefly, what Gödel's theorem says is that a system, a mathematical system that is self-contained, can ultimately reach its limit. It reaches a certain limit. So if any mathematical structure that you build eventually becomes inconsistent.
There are theorems that are unprovable.
There are theorems that are unprovable within a particular scientific mathematical framework you develop. So Gödel's theorem is very, very important here, and ultimately provides, I would say, a limitation into mathematical description. I guess that's what Stuart was saying, of the universe based on just computer algorithms which can explain everything.
Does it suggest creativity?
Clearly, creativity is beyond Gödel's theorem. It's beyond mathematics.
No, I guess I'm in the I don't think Gödel's theorem is particularly relevant to physics camp.
I don't think it's. I just say something very quickly about it with biology. I don't know that it's relevant to biology. I think the interesting thing about Gödel's theorem is that while it looks like a limitation, it looks like some sort of limit on mathematics, whatever, actually what's, I think, so remarkable about it is that from such a relatively small body, although brilliant body of work, so much has come out of it. Ideas about recursiveness, paradox, and I think these things may actually turn out to be of some value. Complementarity. Yeah. May actually turn out to be of some value in descriptions of consciousness or conscious processes. I'm not sure about that. I'm not a good enough mathematician.
Hello, gentlemen. My name is Christina Kutavalis, and I want to tell you I've learned a lot from you all. I've watched your inner islands, and I believe we all have that. An inner island. Some have water, some have, a hammock, and some have weeds and so forth,
weeds.
But I feel like everything has been so... No, you've been actually most fascinating.
Let's talk after.
I do believe that there is an ultimate reality, and there is a purpose to life. And there's an innate impulse in us. It's a rhythm. It's an essence. And when we're born, we're at our full capacity. And I don't know, somehow, we've got, I believe there's like all these different times. There's chronos, there's kairos, there's conditioning from when we're little, there's when we first put meaning to something as a child, and we carry that with us through our lives until we realize that's not our highest possibility or our authentic self. And then I look at, that I think it's called the pineal, which is like someplace in the middle of the brain. There's the left brain, there's the right hemisphere. Hopefully that it moves like this and it's just not over on one side. But in the Bible, I know it says to be in the right mind, and I always questioned what that meant. And then on my walk of life, the search for identity is why I believe we're here, and that we need each other to accomplish that. And I guess what I'm trying to say is that when you look at people, sometimes you see more enthusiasm, or you see something that they're filled with, and it's an essence that you can't put in. You can't put in figures or mathematically, because it's beyond. I believe God put something called the conscience in us, and a thirst to keep searching, and that's why we're all here. We're searching. So I don't know. I'm just wondering. All this has been very left brain oriented, and a couple glimpses of the right brain. And I don't know what the quantum physics is all about. I really wanted to ask what that is, but I have had quantum moments that I've had quantum moments that have literally hopped me up a few stairs up the ladder where I'm breathing differently, So I just wanted to ask also, you had said there was no purpose. And I just wanted to ask if everybody else thought there was a purpose to life.
There goes your eye.
No, I didn't say that.
You did.
I think I was asked if there was.
We'll come back to this.
I think I was asked if there was an ultimate purpose,
yeah.
and I wasn't willing to go for the ultimate bit.
Would it be the same thing as the purpose of life?
Well, okay.
He's very careful about how he uses language. Yes.
I wanted to ask to get back to the ecological threat and the fact that so much use is being made in computer simulations, both to try and figure out where we might be going, and when all the theories are wrong but useful and so forth. Here we are relying a great deal on this kind of thing. At the same time, we're training our young people to live inside these simulations, whether in avatar-type worlds or online and so forth, to the point that they really, humility or not, whatever God would want in terms of symmetry or whatever, they really can't distinguish as well as somebody with a physicist training, between what they're saying. So we're training people to accept these worlds, which are actually have less information than the physical body, can bring in at the same, though they process huge amounts of information. How reliable do you think that is in terms of a societal strategy for dealing with the ecological problems to come, and from the point of view of training large numbers of people?
Yes, these computer models you're referring to, the global circulation models, there is a lot of debate going on back and forth about their validity. Unfortunately, it's not a full picture. And I would say that both sides of the argument, those who reject those model results and those who embrace them, they're both wrong, or if you like, they're both right. It's not a complete picture. What we need to do is to take a look around us, what's happening now, not what's going to happen 50 years from now. And a lot of this debate is going on about 100 years, 50 years to the future, whereas right now we have 200, 300,000 people born every day in the world. We have species that are becoming extinct all the time. Everybody knows about the polar bears, but that's just one of the many species that are becoming extinct. So there is, unfortunately, there's very little humility on both sides of the argument. And I would say that a lot of us, climate scientists, what we're doing now is take a look at what's happening right now, try to understand from observation from space what's going on, rather than taking categorically one or the other answer.
The only thing is we have to be careful before you condemn technology, because for one thing, it's unstoppable. There's no way we can stop the... So the bigger question is, how are we going to use this for wholeness, and how are we going to use this? And that depends on our own personal identity, whether we are separate from it or we are an expression of it.
Or a responsibility to educate the next generation.
Absolutely.
Absolutely.
I want to go back to Gödel's theorem. I think it does have a particular relevance to the questions that you started the discussion on, which is what's the evidence or what arguments can we give for an observer-independent universe? Gödel's theorem proves that relative to some systematic set of axioms, like any from various branches of mathematics, there are some truths that exist that cannot be proved. So
using those axioms.
That's right. So doesn't that provide evidence that there are things that exist independently of anyone's ability to prove them?
No, I mean, unless you're talking about mathematical existence. I mean, it's...
Well, mathematics is invoked as the language of nature, so I would agree with it.
Well, this is where... Okay.
The idea was that mathematics was what would lie behind physics, which would be what lies behind chemistry, biology, etc.
Okay,
so if it can't be proved to exist, if it can't be proved in mathematics, it can't be proved.
Well, so I guess my theme is that things like math are useful tools that we use to try to understand more about how the world behaves, but I don't want to confuse the tools we use with that world itself.
But I take it that the proof sort of agrees with you in saying that there are things that cannot be proved through the system.
Within mathematics, yes.
Within mathematics, yes.
Well, what else would you use to determine, to describe?
You're absolutely right. I think that's why I said that we need a new kind of mathematics that will be really more the qualitative aspect. But even that will have its limit. You're totally right. Gödel's theorem says that you cannot have a self-consistent picture of the physical reality that ad infinitum provides consistency at all levels, because mathematics is the language of interaction with nature. That's what Bohr said, that's what we all believe. It's the language of interaction. As any language, as we all know about languages, they have limitations.
And that intelligence and consciousness is non-computable and cannot be put into an algorithm. That artificial intelligence will never simulate the real intelligence of nature, because it has axioms that are unprovable, that suggest discontinuity, creativity, imagination.
But Gödel's theorem uses mathematics to prove that things exist.
We're agreeing with you, sir.
We're agreeing.
Totally agreeing with you.
We're agreeing.
Maybe he's not,
so
but we
the
are.
issue of non-computability isn't relevant. It's computable. You can compute that there are things that cannot be determined in that system.
Perhaps we're using the word computability differently.
Penrose's non-computability means an outside system. Some system from the outside is needed to give the final answer or effect. That's all it means.
Next question.
For simple souls such as myself, there is a book that I'd like to plug, which is by Ian McGilchrist, called The Master and His Emissary, the Hemispheres of the Brain and the Making of the Western World. And for me, it explains an awful lot about the context of how this kind of conversation happens, which is a hugely important conversation, but it does give reason for their having a more integrated view in terms of where we're going and the way of the world. Anyway, Ian McGilchrist's book's been very well received in the UK, and nobody knows about it over here.
Thank you. Thank you.
Hi, my name is Soraya Brukim. I'm a healer, and I'm very frustrated because I myself have witnessed consciousness, and I work with consciousness, and I want to go beyond to be able to prove it, as we're all here for that. But my question is, if we can't use language, and I firmly believe that it exists, and I firmly believe that it's really important in order to save lives, how can we all come together or find another way and go beyond that? And what is there to do? And I ask that because it is very important for the survival of our Earth, the survival of us as a human being, as humanity, and also to save lives in the hospital with doctors. And what can we do to create one language, with what I feel and what a doctor sense, or beyond science and that?
Okay.
Can I
so
try?
I can say something very quick.
Yeah.
I don't have any doubt there's such a thing as consciousness in the normal sense of the word consciousness, just like I had no doubt there was such a thing as this jug. The same thing goes with consciousness. What you're talking about sounds like we want to be able to communicate more effectively, and I think that's motherhood and apple pie, right? Everyone would agree we want to be able to communicate more effectively. So what I didn't quite get was, what do you see as the barrier, the special problem? Yes, we all want to do this.
I think the barrier is that there isn't there isn't a acceptance that it does exist universally.
Should we have a vote? Does anybody?
No.
Who thinks there is no consciousness?
Well, I feel like
something else.
I'm thinking more the theory and feeling, to prove feeling. This is a huge question, but to prove, because I don't. We said, it's through experience. You mentioned it's through experience, and how can we bring what I witness or what I experience?
I think what Soraya is saying is, in at least the scientific circles that we are part of, very little credence has been given in the past to subjectivity as a valid experience. And now we are seeing with all the studies that the monks and the Dalai Lamas on how, even thinking about love or compassion or evoking the feelings of equanimity bring about neurons firing together to lay down new neural tracks, the whole area of neuroplasticity, and also genetic modulation, because in order to lay down neural tracks, you have to work through genes, RNA and DNA transcription, translation. So we are seeing now that subjectivity actually modulate the structure of the brain, if we want to call it a structure. And what she's saying is that in the past, perhaps we have not, I know that as a physician, we were dismissive of subjectivity. I don't feel good, I'm this, I can't sleep, I'm worried, it's all in your mind. Well, in fact, that was the schism, the mind and the brain, the mind and biology, when it's all one process. And perhaps you're hinting at that.
Can I address?
I would indicate.
Yes.
I would indicate.
Stuart, okay.
Oh, okay.
Well, I'm a doctor. I'm an anesthesiologist, and I usually don't see my patients until about 5 minutes before I take them back to the operating room. Unlike a lot of people, healers and physicians who see their patients over many, many years. But that first instant when I see them, I look them in the eye. I relate to them, I emote to them, and they emote back to me. I think I'm entangling with them in the literal sense of quantum entanglement. I think quantum entanglement establishes a relationship between people, and I use that. I give them post-anesthesia, so you're going to wake up feeling wonderful, you're going to not have any pain, I don't say you're not going to feel sick, because that would plant a seed. I just say you're going to feel great when you wake up. And then I say something funny like, I've never lied to you before, have I? Because I just met him. And so humor is also a good part of it. So the point is that this personal side of it, and of course you could say, well, it's a placebo effect, but I think it's more than that. I think you actually relate to the person and entangle with them. So let me use that to make two comments. the physicist said that, reductionism, classical neuroscience can explain consciousness. The neuroscientist said, well, I'm not sure consciousness exists. So we have a problem there. I think you have to go beyond reductionism and beyond what's present neuroscience into quantum physics, quantum biology, to explain consciousness, to get down to what Deepak's talking about, which is more of a mystical approach, because I think there's a middle ground. I think the Penrose approach is right in the middle between what they're talking about and what he's talking about.
What hospital are you on?
University of Arizona Medical Center. We've been in the news the last couple of weeks. In case
you did well with one patient.
We did well with all those patients, by the way. Thank you very much for saying that.
In terms of what you're saying is, we scientists need a lot more humility than we really have. We think we contain the entire universe in our thoughts. That's just not the case. I would say that let's take a look very seriously at what has been written down for many, many ages from what I call the perennial philosophies. I've written a lot about this, both from the West and from the East. They were talking about some certain experiences that were subjective. However, they had a certain objectivity. They could be repeated by meditation, by certain inducing certain states. Let's go back to these ancient writings and see what they say. And in fact, if you go back to, let's say, the Puranas, the Indian Puranas, you find in those writings they're talking about age of the universe that is way beyond 13 billion years. They're talking about 100 billion years, 200 billion years. How did these ancient sages know about these timescales? So there is a lot of knowledge that's already there, which we in the West, if I can simplify things, have rejected because we say, well, our science is all there is. So a little bit of humility will go a long way, starting from the wholeness, right? Starting from the entire big enchilada, if I can call it, and getting down to the parts rather than trying to build the big picture from the parts.
Okay, so, we've come to the end of our conversation, more or less. I think I'll leave you with one little phrase from Václav Havel's inaugural speech many years ago. He said, seek the company of those who are looking for the truth and run away from those who have found it. So I think we're in the right place. One last thing. The cameras are going to go downstairs, and if you're watching this downstairs, they're going to ask you, what did you learn? Do you have any more questions? Do you have any ideas? What is ultimate reality? What's your opinion? And please, if you feel compelled to say anything, we'll get a lot out of it, a lot of feedback. I want to thank you, Edward, and thank you, sir, for hosting us. This has been a wonderful...
There are also books for sale.
Oh, there are books for sale as well from all of us.
Thank you, Deepak.
Thank you. Thank you very much.